Section 12.2, picking up where we left off with number 21, we were calculating the surface area. So if we simplify this, we would get surface area is equal to 49.6 pi plus 32 pi which would be equal to 81.6 pi, and then we can type that in on our calculator and approximate 256.4 square inches. Number 23, the largest beverage can was a cylinder with a height 4.67 meters and diameter 2.32 meters. What was the surface area of the can to the nearest tenth? So if the diameter is 2.32, first of all, that would make our radius 1.16 meters. And if we're looking for surface area, then we want the lateral area plus 2 times the area of the base. Where our lateral area is found by taking the perimeter times height, and the perimeter of a circle is the circumference. So we end up with the circumference, which is 2 pi r times height plus 2 times the area of the base, where the area of a circle is pi r squared. And then we just have to substitute in. So our surface area will be equal to 2 times pi times radius of 1.16 times a height of 4.67 plus 2 times pi times 1.16 squared so 2 times pi times 1.16 times 4.67 plus 2 times pi times 1.16 squared using a calculator and approximating gives us 42.5 square meters for our surface area. For number 25, we want to use the given lateral area and the diagram to find the missing measure of each solid, round to the nearest tenth if necessary. So we are given the lateral area is 635.9 square centimeters. The height is 11, and we want to find the radius. So the first thing that we want to do is write down our formula for lateral area of a cylinder. Lateral area is always perimeter times height. Perimeter of a circle is its circumference, and the circumference can be given by the formula 2 pi r. So if our lateral area is equal to 2 pi r h, and we want to solve this equation for r to get r by itself, we need to divide by 2 pi and by h. In other words, we want to get those values to cancel out. So we divide the other side by 2 pi h as well. So our lateral area divided by the quantity of 2 pi h will be equal to our radius. Now we can simply substitute in our known values. So our radius will be equal to 635.9 divided by 2 pi times 11. So to our calculators, 635.9 divided by the quantity 2 times pi times 11 gives us approximately 9.2. So our radius is approximately 9.2 centimeters. For number 27, a cylinder has a surface area of 256 pi square millimeters and a height of 8 millimeters. Find the diameter. So to find our diameter, diameter is equal to 2 times the radius. So first we have to solve for the radius. Since we're talking about surface area here, we're going to write down our formula for surface area of a cylinder, which is 2 pi times the radius times the height of the cylinder plus 2 times the area of the base, where the area of the base is pi r squared. So we're just going to begin to substitute in what we know. We know the surface area is 256 pi. We know that our height is 8. And we get this. Now notice these two terms are both divisible by 2 pi. This term as well, since it's an even number with pi in it. So in our next step, we're going to divide both sides of our equation by 2 pi in order to simplify. So 256 divided by 2 would be 128. Pi cancels. So 2 and pi cancel here, and we get 8r. 2 and pi cancel there, so we get r squared. From here, we notice that we have a quadratic equation, so we want to get it into standard form, which means that we want our r squared term to be first, and then our r term. And we want to bring this constant term over to the other side, so we're going to subtract 128 from this side and 128 from the other side. Now that we are here, we can solve this by either using the quadratic formula, or we can see if it's factorable. To see if it's factorable, we want factors of negative 128 which have a sum of 8. So if I take 16 times negative 8, I get negative 128, and 16 plus negative 8, I have a sum of 8. So my two numbers would be 16 and negative 8. So we want to rewrite this as, instead of r squared plus 8r minus 128, we would have r plus 16 times r minus 8. And remember, once again, we can double distribute or FOIL this, and we should get this back. From here, we are wanting to solve for r, so we'd set each factor equal to 0 and solve for our variable. So r is equal to negative 16 in this case, r is equal to 8. Since we're talking about a length, that would rule out our negative case, so just our positive would work. And if our radius is 8, remember we want to find the diameter, so we want to double that. That makes our diameter equal to 16 millimeters. Number 29, the graphic shows the results of a survey in which people were asked where they like to watch movies. Part A, suppose the film can is a cylinder 12 inches in diameter. Explain how to find the surface area of the portion that represents people who prefer to watch movies at home. So basically what we would have here is just this, think of a block of cheese. So we'll be looking at something like this, where this part is cut out. And we just want to find the surface area of the rest of this. So to do that, first we'd find the area of the sector. So we'd find the area of this this sector here, and we would double it because we would have that on top and on bottom. Then we'd find 73% of the lateral area of the cylinder, because we just want from here to there and then to stop. We don't want this part. So the 73% is coming from the sector, the portion of the circle that we have. We have 73% of the entire circle. Next, we'd find the areas of the two rectangles formed by the radius and height when a portion is cut. So basically there's a rectangle here and then there would be a rectangle here. That's not the best way to look at it. If we drew it this way, we would see that for the block of cheese, you can see if you want to think of it that way, we would have this rectangle in here and this rectangle here, which is made up by the height of the cylinder and the radius of the cylinder. And then lastly, we would find the sum of all those areas. And so that's what we're going to do in part B. So if the film can is 3 inches tall, so our height is 3 inches, find the surface area of the portion in part A. So in part A, it said that our diameter is 12 inches. And once again, we want 73% of the entire cylinder. So, quickest thing to do would be to find our radius, which would be half of the diameter. So we have 6 inches there. And then we're just going to go through these steps right here. So we want to find the area of the sector and double it. So the area of the sector would be the area of the circle, which is pi r squared. Radius is 6, so pi times 6 squared. And then only 73% of that though, so times 0.73. So if we do that and leave it in terms of pi, we would get 52.56 pi. Basically, I'm just taking 0.73 times 36 to get that. The next thing that we want to do is find 73% of the lateral area of the cylinder. So our lateral area is our circumference times our height. So we want 73% of 2 pi radius times height. So if we simplify all this, take 0.73 times 2 times 6 times 3 and leave it in terms of pi, we get 26.28 pi. Then it goes on to say, next find the areas of the two rectangles formed by the radius and the height when a portion is cut. So those rectangles, there are 2 of them, they're congruent. So 2 times the length times the width, so radius times height, and we get 36 there. Last part is to find the sum of all the areas. So we want to add all these up. Take 52.56 pi plus 26.28 pi plus 36, and our sum is equal to approximately 283.7 square inches. For number 31, find the lateral area and surface area of each oblique solid round to the nearest tenth. So an oblique solid is just one that's been slanted over, like what we have here. So our lateral area is equal to perimeter times height. So our perimeter of our base is pointing to this face as the base. We would have 20 along this side, and so that would be 20 along the top, and then we have this side, which is unknown. So to find this side, let's just go ahead and call that x. We have an angle, we have a side of our right triangle, so we can use trig to find this missing side. So this side would be opposite, this side is the hypotenuse, so we have opposite